No? Okay. Let's see, we're 16. Come on. So when you log into As You Learn for our class, it will give you the next two exams, when the date is, and when your final exam is. The next two exams will be similar to the setup that we had on this last one, where there'll be part take home and part in class. The final exam, I'm not sure though. That one might be all just in online live, simply because you have 2.5 hours, which is a lot of time. Um, so it might all be in class. I'm not sure. But definitely the next two exams will be similar in setup and time as the last. Any questions on that? Any questions? Everyone can hear me, right? Okay. Um, any questions on the project? Remember, it's due Sunday for 50 points. Okay. Then we will continue where we left off last class, which was on limits. We had done, last thing we did was the limits where you get 0/0, and so we needed to factor and reduce. But there's two other cases when you have 0/0. One of them is complex fractions. So this would be case 2. If we have the limit as x approaches 0 of 1 over x plus 2, I'm making a negative one, plus 1/2 over x. So if we had something like this where we're finding the limit as x approaches 0, then of course, remember, the first thing you do is plug this value in, whatever it is, and see what you get. So if we plug 0 in here, we get negative 1/2 plus 1/2 is 0 over 0. Now, if it was just polynomials, we would try factoring, but this one is a complex fraction. So what you want to do to reduce complex fractions, trying to make that there, that looks clearer. To simplify a complex fraction, you look at the little denominator. So this one would be a 1. So we wouldn't have to worry about this one. But you take the common denominator of the smaller values, which is 2 times x plus 2. But you have to multiply all three terms by it. 2 times x plus 2. That came from these two denominators. Now the denominator one, don't multiply that out because we want to get that original x to cancel. So don't distribute the bottom. And this is a times, not a negative. Any questions so far? I just took the smaller denominators. I'm going to multiply all three terms by it. Looking at the first one, the x plus 2's cancel. and they leave -1 times 2, or -2. Over here, the 2's cancel and leave this +1 times these. Now, of course, +1's not changing anything, but if you had a -3, you need to be careful that it gets distributed. And if you have a negative, carry it with it. It's got to distribute through. But since it's a +1, it doesn't change it. It's still positive x plus 2. And we're going to leave the denominator as it is. And then remember to bring your limit down. Sometimes what I do is I work all of this out, and then when I'm ready to use it, I bring it down. Or you can rewrite it each time. We still don't want to plug that 0 in because we didn't get rid of that original x. But notice on the top, we can combine the -2 and the +2. They drop out and just leave x on the top. So we have x over x times 2 times x plus 2. Notice now the x's will cancel. What we have to decide is there's nothing left on top. What should be on top once that x cancels? Anyone? When there's no number in front of your term, it's a 1. There, someone typed it in now. Thank you. When there's no number in front, it's a 1. So when these x's cancel, it leaves a 1 on top. We have the limit as x approaches 0 of 1 over 2 times x plus 2. Now that this x canceled, plug it in, see what happens. 1 over 2 times 0 plus 2. That would be 2 inside parentheses times 2 gives us 1/4. Any questions on that one? Okay, let's try another one. Well, we're going to do the next kind, I guess. Is there any questions on the complex fraction? The other case is if you have a radical. So if we take the limit as x approaches 36 of the square root of x minus 6 over x minus 36. First thing, plug it in, see what happens. So we plug it in. Are we getting 0 over 0? The square root of 36 is 6, and 6 minus 6 is 0. And then 36 minus 36 is 0. So that means we have to find a way to simplify. Any questions on that part? When you have two terms and one of them is a square root, in order to simplify them, you multiply by what's called the conjugate. So we're going to take our square root of x minus 6 and our x minus 36, and we're going to multiply by the top's conjugate because we want to get rid of that radical. The conjugate is the exact same quantity but the opposite middle sign. So it would be, in this case, the square root of x plus 6. And when you have a fraction, whatever you do to the top, you have to do to the bottom. Again, don't multiply the bottom out because we want this original part to cancel. So we only need to multiply the top. Any questions so far? So we use the conjugate, and we multiply top and bottom. The nice thing about the conjugate, you only have to multiply the first two and the last two, because when you're foiling, the outside and inside cancel. So we only need the first two and the last two. And the square root of x times the square root of x is just x. When you multiply a square root times itself, that would be the square root of x squared, which is just x. So multiplying a square root times itself just gives you what's inside. Square root of 2 times the square root of 2 is the square root of 4, which is just 2. So when we multiply these two first terms together, we get x. And then negative 6 times 6 is a negative 36. Any questions on that part? So I just multiplied the first two and the last two because this is a conjugate. I don't need to multiply the other two. If you did, you'd have a negative 6 square root of x and a positive 6 square root of x, which cancels. Just like the last one, if we're canceling everything that's on top, it leaves that 1. Just remember, in front of your quantities or in front of your variable, when there's no number, it's a 1. We don't have to show the 1. So the x minus 36 cancels. Once that original quantity cancels, you can try plugging it in again. I'm plugging in 36, 1 over the square root of 36 plus 6. Square root of 36 is 6 plus 6 gives us 12 in the denominator. Any questions on that? So that was 0 over 0. Was there any questions on those? We did when 0 was divided by a number, that was just 0. And 0 over 0. The other case, when you plug in the value and you get a number divided by 0, because we know we're not allowed to divide by 0. What happens is the limit does not exist. But it approaches positive infinity or negative infinity. And so you need to decide. And sometimes because it's going opposite directions, you need to take the limit from the right and the left of those values if they're going in different directions. Let's look at one. So we have the limit as x approaches -1. First thing we would do, plug it in. So anytime you get a limit where it's going to a number, plug it in and see what happens. -1 plus 5, -1 plus 1. Well, we're getting a 4 on top, but a 0 on the bottom. The smaller and smaller your denominator gets, the closer, or like not close, the larger it gets. pencil died. Okay. So dividing by 0, it does not exist. But then we need to check for positive and negative infinities. One way of doing that is a graph. So I will show you the graph, and then I'll show you another way. There's 2 ways. And we want to check from the left and the right because it could be different. So if we look at the graph, now we know we're using -1. So first we're going to pick a window. Now if you want to do this on Desmos, you can. Just plug in this graph. Or you can use your TI-84. So I would first check my window on here. This will almost always work when you're finding limits to a value, as long as your value is within this range here, and -1 is between -10 and 10. So this X value has to be in your window. And this one usually works for these types of problems. Then go to Y equals and plug in your value. Oops, sorry, I didn't mean to hit graph. I meant to hit clear. So if I plug in my value, x plus 5 divided by x plus 1. You will want it in parentheses unless you use a fraction bar. So unless it will write it one above the other, you need parentheses. And then go to graph. If you have a TI-84, it does not show the asymptote. There's actually a dotted line, a dotted vertical line at -1. If you have a TI-83, it shows a solid line right here. If I look at the graph, at -1, there should be an asymptote. And that's where that break is right here. And then the graph's going this way. This way. This first limit, because the reason I'm doing both is, notice as I'm getting close to that dotted line, they're both going in opposite directions. If they both went up, then technically you could just put the 1 and put infinity. On a test, I would specify how I wanted you to do it. But because this one's going in opposite directions, you should show both. The first one, the plus, is from the right, because you're going a little bit larger than -1, so you're over here. My graph's up here, it's going up. It's going to positive, so the limit doesn't exist. But it's going to positive. My pencil keeps breaking. It's going to positive infinity. But this one, instead of going up, because we're looking on the left, a little bit smaller, that's what that little minus up there means. We're looking on the left side. Our graph's down here. It's going to negative infinity. So in these cases, when the limit does not exist, you also need to state positive or negative infinity, depending on what the case is. Are there any questions on that?
Did you say when we're putting it into our calculator, we just do it in the y equals screen?
Yeah. So you put the equation in the y equals screen.
Okay. I've
And
done that,
then,
but it's telling me when I try to graph it, invalid dimension.
and you have parentheses around it.
Yes, ma'am.
Okay. Then let's check what your window. Although the
Let's see, negative 10, 10, 1, negative 10.
And make sure your negatives are negative and not a minus. Because if you do put a minus, it will give you a dimension error. Is it coming up now?
No, not for me. And I've got it in the the window the way you've set up, and I'm not sure what's got. Yeah, it says invalid dimension.
Hmm. You only have the equal sign highlighted, right? Not the plot. None of the plots are highlighted, right?
No, ma'am.
Hmm.
Oh, wait, hold on. Yes, plot one was highlighted.
Okay, that could be what's causing it then.
Okay.
You
How
might not have
do I
anything.
get rid of that then?
Okay, so you just go push up to it and
Okay.
then hit enter. See, when I did it, it highlighted it. So
Okay.
then if I go back up, hit enter, it will unhighlight it.
Ah, okay. One, and there we go.
There. See that?
Got it.
Yeah.
Thank you so much for
Oh,
that.
you're welcome. It's a great calculator, but it takes a little bit of time with the technology.
No kid.
But you're going in opposite directions. So one way of solving this one is by that. Now, another thing you can do instead of typing it for like the first one. Oh no, that's infinity. Yeah, that would only be, you could plug in numbers. Remember when we did the table, this? You could plug in numbers from the right and the left and see what happens. So if we went to table, second and table, we're at -1. So if we go a little bit larger than -1, -0.9, -0.9, -0.999. Notice how as I get closer and closer to 1, well, -1, this one rounded because I put too many nines. But the closer and closer I get to that, the larger and larger and larger this is getting positively. So that's why it was positive infinity. So you can always go in and plug numbers in close to your, in this case, -1. For this one from the left, I want to go a little smaller. So -1.1, -1, 1.01, -1.001. From the other side, I'm still getting large, but I'm getting large negatively. And that's why it's negative infinity. So that's another way of checking it. You could plug in those values in your table and see what happens. And this just keeps getting larger and larger. Any questions? Eventually it will round. Um, but when it does round, you could always highlight it. Notice when I went here, it gave me the number I entered. And when I go here, it gives me, well, that was all the numbers, but any questions on that? Okay. The next type of limits, instead of plugging in values, we have limits to infinity. But is there any questions on this one? So you can look at the graph or you can plug in values in the table. And all limits where you're plugging in numbers, you could do that. You could use the table. The next ones we look at is limits to infinity. Finding limits to the infinity is similar to finding the horizontal asymptote, which we haven't really covered yet. But if you remember your rules from here, it will help when we find horizontal asymptotes. The first case is the degree. If the degree of the top equals the degree of the bottom, then take the two leading terms and reduce them. Now you're probably asking, what's a degree? When we have a polynomial, the degree is the largest exponent. So if we had the limit as x goes to infinity of 2x squared plus 6x minus 9 over 4x squared plus 2. The degree of the top is 2. It's your largest exponent. The degree of the bottom is also 2 because the largest exponent is 2. When that happens, because we're talking about a really large number, it's going to approach these two. So adding 2 to $1 billion doesn't mean much. Or if this goes to 1 billion, this little extra here isn't going to change it much. So we will still be approaching this. So we can just drop this off. And then reduce. The x squareds will cancel. 2/4 is 1/2. So when x gets large, the y value approaches 1/2. Any questions on that? We'll try another one. The limit as x approaches negative infinity, 8x plus 2 over 4x minus 5. So the first thing you want to do is look at the degree of the top and the degree of the bottom. What is the degree of the top? Anyone?
Would it be 1?
Yes. Remember, when there's no number, it's a 1. So the degree of the top is 1. Is the degree of the bottom the same?
Yes.
Exactly, because I haven't taught you the other ones yet. But the degree of the top and the degree of the bottom are the same. When they're the same, take these two largest terms and reduce them. 8x over 4x. The x's cancel. 8 divided by 4 is 2. So as x gets negatively large, y approaches 2. Any questions on that? Need to do one more? The limit as x approaches infinity, x squared plus 2x minus 5 over 3x squared plus 2. So go ahead and find the limit as x approaches infinity. Degree on the top and the bottom are the same, right?
Hmm.
They're both 2. So they're both 2. X squared over 3x squared gives us what? Anyone?
1/3.
Exactly 1/3. Because remember, when there's no value in front, your coefficient's a 1. Any questions on that? Now your book's going to show you another way, and probably my labs. What they're going to do is they're going to take the largest variable with the largest exponent and divide everything by it. So what they do, x squared over x squared plus 2x over x squared minus 5 over x squared. And you have to do it for every single one. Now what happens is if your degree on your top is smaller, those go to 0 because the limit as x approaches positive or negative infinity of 1 over x is 0. So these go to 0. X squared over x squared reduces to 1. X squareds cancel, 3. So you're going to get the same answer. I just think that's a lot of work when you could just look at the degrees and get the same answer. And then once we learn the quick form of the derivative, you can just take the derivative of top and bottom. But this is still the quickest and easiest way. So if you see this on my labs, they're just showing you the long version that you would use as a proof. But you can do it this way. Any questions on when the degree of the top and bottom is the same? The second case, the degree of the bottom is larger. This one is really nice. Because if you think about it, if you take a small number and divide by a large number, it's getting really close to 0. So the limit is 0. So if the degree of the bottom is larger, the limit is 0. You don't even have to think about it. If we had limit as x goes to infinity, 2x squared minus 1 over 3x to the 4th plus 2. Find the degree of the top and the degree of the bottom. Degree of the top is 2. I'm getting that from the exponent, not the coefficient. So the degree of the top is 2. The degree of the bottom, 4. Degree of the bottom is larger. So my limit, 0. Any questions on that? So if the degree on the bottom is larger, it's 0. We'll do another one. Using the same values. So negative 5x squared plus 6x over 3x to the 4th. Degree of the top and the degree of the bottom. The degree of the top is 2. The degree of the bottom is 4. The bottom is larger, the limit is 0. Any questions on that? Now on all of these, if you wanted, you could plug this into y equals, and then go to your table and start plugging in this case, large negative values. And the larger your negative value is, the closer this will get to 0 until it finally rounds to 0. Any questions on it? So if the degree of the bottom is larger, it's just 0. The last case, the degree on the top is larger. When the degree on the top is larger, the limit does not exist. It is positive or negative infinity. Because your top's getting large. If you take a small number and divide it into a big number, you're going to get a really big number. And so if the top is larger, the limit doesn't exist because it's getting huge, either positively or negatively. If we have the limit as x approaches infinity of x to the 4th minus x cubed minus 3x over 7x squared plus 9. Okay, first thing, check your degrees. And we'll notice that the degree on the top is larger because the degree on the top is 4, the largest exponent, and the degree on the bottom is 2. The top is larger, so the limit does not exist. Now we have to decide if it's positive or negative infinity. It's only one of them. Any questions on that part? Now, one way of checking it, you could graph it and see what happens in the graph. Another way, because this is positive infinity, we can take this and plug in a positive 1. Now, just like we did the leading terms before, you only need to look at the leading terms. You don't want to look at all of them, because then you'd have to put in a huge positive number to get it to work. But you can just take the leading terms and plug in, this is positive infinity, plug in a positive 1. And we get 1 to the 4th over 7 times 1 squared, which is a positive number because we have 1 over 7. That means this is positive infinity. No, we'll graph it also so you could see that. But if instead of being positive infinity, if it was negative infinity, it still would not exist. And we still need to decide if it's positive or negative infinity. Now, instead of plugging in a positive one when it's negative infinity, plug in negative one. But again, you just use your leading terms, one on top and the one on the bottom. Negative 1 to the fourth is a positive one. Negative 1 squared is 1 times 7. So we're still getting a positive answer. So it's positive infinity. I think it's quicker than typing the equations into the calculator, but I will show you what happens if you do. So if we type the whole equation, x to the fourth, there we go. So if we enter it, and I'm going to leave the same window and hit graph. This first one was x going to infinity, and as x is getting large this way, y is also getting large positively, and that's why it was positive infinity. This was going up. Looking at the second one, negative infinity, that's when x is going this way, it's getting negatively large, y is also going up, just like this side, so it's going to positive infinity again. So either way, whether you look at the graph or you plug in a positive or negative one, now you don't have to do it for both, you only have to do it for whichever one you would be given. But both ends are going up, so that's why they're both positive infinity. Are there any questions on that? Let's try one more. The limit as x goes to infinity, negative 5x cubed minus 4x squared plus 8 over 6x squared plus 3x plus 2. So again, the first thing we do is look at the degree. The degree on the top is 3. And the degree on the bottom is 2. Comes from your largest exponent. Now be careful, sometimes they may not be in order. My math lab may move things around, but it's your largest exponent on the bottom and the largest on the top. In this case, the degree on the top is larger, so the limit does not exist. Now we need to decide if it's positive infinity or negative infinity. Any questions on that part? So the degree on the top is larger, does not exist, and we got to pick one. We can take the two largest terms, one on the top and the one on the bottom, and plug in, this is positive infinity. You could pick any positive number. I use 1 because it's quick, but it can be any positive number. Negative 5 times 1 cubed over 6 times 1 squared. On the top, we're going to get a negative 5. On the bottom, we'll get a positive 6. Our answer is negative, so it is negative infinity. If our answer was positive, then it would be positive infinity. Any questions on that? Try one more. Oops, sorry, I didn't see it. Let's try this one. So first we do the degree. The degree on the top is 2. The degree on the bottom is 1. So the top is larger, which means my limit does not exist. I need to decide if it's positive infinity or negative infinity. This is a negative infinity, so I want to plug in any negative value, and you only use the largest degreed term on top and bottom. I'm going to use -1 because it's the easiest. We have negative. Now you want to be careful here. I always put parentheses when I plug things in because this is not negative times a negative, a positive 1 squared. The -1 needs to be squared first. So -1 squared is 1 times this negative makes it a -1. On the bottom, 6 times -1 is -6. So this is a positive answer, which means we're going to positive infinity. Is there any questions on that? Positive. There's a couple story problems I'm going to do in these 2 sections, but I will do them next class. Is there any question?